Welcome to Structural MD Podcast, episode 006. You know what the next one means, 007, some James Bond stuff. Not sure how much James Bond has to do with 3D printing. For all we know, he could have had a 3D printer in that trunk of the Aston Martin. Hollywood likes to keep a lot of tricks up their sleeves that we'll never know about. Anyway, I'm your host, James Hilligus, and today we are going to be covering big area additive manufacturing. Now, I'd like to preface this podcast episode with one thing. This technology is a little bit new, and you might feel that this podcast is a little bit incomplete, and understandably so. With that being said, I will be making a sequel of this podcast in a couple months or so. I hope to gain access to a couple people, to interview them, to bring them on the show, and to really get a better understanding of the technology, the ins and outs, to provide some value for you guys, so you also better understand the technology. With what I know, let's just jump right into the podcast. So the technology was developed at Oak Ridge National Laboratory, which is located in Tennessee in the United States. The technology was then licensed to Cincinnati Tool, which is located in Cincinnati, Ohio, to be manufactured and then sold to whomever wanted to purchase it, whether it be companies, universities, etc. To date, as of me recording this podcast, which is January 11th of 2017, only 11 machines have been manufactured. So that'll be an interesting point. I will definitely bring that up at the end. I have some very interesting news for you guys that some of you might be interested in. Yes, I also understand this podcast probably won't be released until the spring, but I'm trying to record a bunch before the school semester gets started in a week. So in case I fall behind in my recordings, I don't get off schedule. Little trick up my sleeve. I let you guys into the dark magic world of my podcasting. So the mission with big area additive manufacturing, which is often abbreviated as BAM, B-A-A-M. Like I said, we love our abbreviations. The mission was to take 3D printing to an industrial scale. Before, 3D printing was relatively small. Not too many industrial-sized things could be even simply manufactured, which is why fields like biomedical were so easily able to adopt the technology. And not easily able to adopt the technology in as the sense that, it was so easy, it was like making a cake. What I mean is, it was so easy in the standpoint that the field was just primed, if you will, to using the technology. The build volume was small, and most things inside the human body are small on a relative scale. From my standpoint, not being a doctor, being a civil engineer, the femur, I believe, is the largest part of the body. And outside of that, there's nothing really on that size or that scale that can't be manufactured in a 3D printer. Now, you might not need to make everything in a 3D printer for biomedical, but nonetheless, that volume or that size limitation was not as big of an effect as it is in other fields like mine, civil engineering. BAM, big area additive manufacturing, is really similar to FDM. It deposits high-performance engineered thermoplastics via a melt extrusion process. It's really similar to FDM, it's just on a larger scale. I've attached some videos for you guys in the show notes at structural-md.com/P006. Some are just simply an overview of the technology. You get to see the scale of the printer. And a couple of the other videos are some of the really interesting things that have been printed. One is a Shelby Cobra. Some of you might have heard of that. That was kind of big news when that came out in 2014. And the other thing is a submarine that was printed for some Navy SEALs by the Navy, partnered with some universities. Definitely want to take a look at that. I'm going to do things a little bit out of order. I'm going to jump ahead to the advantages and disadvantages of the technology, which really plays into the fact of how this technology came about. So 3D printing on a relative scale, and the scale is the baseline, which is the traditional way of doing things, whether that be milling, CNCing, etc., and so forth, molding, casting, tooling, whatever. The baseline is those traditional processes, and when you compare 3D printing to those traditional processes on an absolute level, if you will, 3D printing is slower, it can't make parts as big, and the material cost is extremely high. So 3D printing was at a huge disadvantage until BAM came along. BAM can print faster, it can print bigger, and the material cost is lower. Now, on the note of why does the material cost lower? Let's touch on that and what materials the technology can print. It deals with engineered thermoplastics, so polymers. It's an open source system, so there's not limited on only a certain brand of polymer or a certain type of polymer. It's open source, so it's thousands of different polymers. And the material doesn't have to be coiled up in a wire or a spool to be printed. It can be in pellet form, which is great for industrial purposes. It comes in pellets on pallets. A little bit of a tongue twister there. Try and say that 10 times fast. They come in typically 1,000 pounds because obviously it's industrial scale, and they're able to use that commodity plastic, which makes the cost basis much, much lower for big area additive manufacturing. But the disadvantage, though, on the industrial side, not everything's plastic. Plastic isn't strong in a mechanical sense. It's strong maybe in the short term, but it's got creep and other things that don't make it as good as metals. But at this time, there's nothing that is printing metals in this fashion. However, as we touched on in episode 005, in regards to the arc welding robots and things of that nature, they might catch up with each other sooner or later. That's yet to be determined. The applications of big area additive manufacturing are really similar to the other applications of the other 3D printing processes that we've covered and have yet to cover. Tooling, molds, custom 3D packaging, custom 3D parts based on what you draw, and prototyping. This is really similar to what the other products or printers service. It's just it can do it on a larger scale. Instead of being limited to a small cubic centimeter or cubic meter build volume, you can print on cubic feet, 6 feet by 20 feet by 5 feet. It's really getting on a much larger industrial scale. The applications are still the same. It's just the scale is what makes the technology so new. That's what's so great. And the fact that it is deposits faster, its print volume is bigger, its material cost is lower. That is the home of big area additive manufacturing. Like I said, this was going to be a shorter podcast episode, and I hope you were able to find some value out of it. I will definitely be trying to bring someone on in a future episode to interview them about the technology. But I made you a promise at the beginning that I had some very interesting news for you, and I wanted to deliver on that promise. Like I said, there's only been 11 printers manufactured and shipped. It costs about $1 million a pop, around that ballpark. The first 10 all went to either private universities for R&D, or they went to companies for private in-house purposes, i.e., John Deere purchased one and they only use it for John Deere type things. I know of a company in Akron, Ohio, and I have a relationship with them, the owners, and they own one of these printers. They just got it, and it should just be installed this week as of me recording this podcast on January 11th. So if you're listening to this podcast anytime after that, chances are the printer is already up and running and servicing. The interesting thing about their printer is that it's a contract printer. It's a service bureau. So anybody can get stuff printed on it as long as they obviously pay for the material. But if you have a CAD file of a large part that you want printed, whether that's a mold, something else that's custom, they can do that for you if you send them the CAD file. You'll let them know what material you want and things of that nature. The link to the company's website, Additive Engineering Solutions, will be in the show notes at structural-md.com/P006. And I also have the emails to the two owners. If you'd like to email them directly, you can email me and I will put you two in contact with them. Until next time, if you guys have any questions, you know exactly how to get a hold of me. I'm more than happy to come speak. And until 007, catch you on the flip side.